Geometry notes, section 1.4. Loosen it up, get your wrists ready. We have lots of vocabulary. I know chapter 1 in geometry is just plumb full of vocabulary, but that's because it's all new terms, it's all new stuff. It's not the same as your regular math. So get a good pencil, sharpen, get a good pen. Here we go. We're going to start with this word. Spell it correctly, please. A-N-G-L-E. Not this. That would be me. This. An angle, not an angel. An angle is two different rays with the same initial point. Two different rays with the same initial point. Sounds an awful lot like opposite rays, but they do not have to be opposite. Here's an initial point. There's a ray, which means it goes infinitely. There's a ray, which means that goes on infinitely. Same point, two rays. They do not have to be opposite rays. Again, you're going to pause this as we go. Sides. The sides of the angle are always rays. Always named rays. Not segments, not lines, rays. The vertex is that initial point. The point that we started with is the vertex. Acute angles. Actually, let me back up. I'm going to draw a picture over here. Go ahead, take your time and draw it on there. If we were going to use this specific angle, and I wanted to name the rays have to start at B and go through A, start at B and go through C. Those are the sides of your angles. So if it asked for the sides, you would say ray BA and ray BC are the two sides of your angle. If it asks for the initial point, remember point is just a capital letter. Represent a point. Do not write point B, just put a B there. We're going to talk about different ways to name an angle, but not just yet. We'll come back to that. You've already heard about acute angles. Acute, obtuse, right, straight. We're going to go through those. Again, you've only been told half-truths. If you think about it right now and you're thinking, what are acute angles? I bet you remember that they're less than 90 degrees. That's close. That's half right. Acute angles are less than 90 degrees. But there's more. They are also greater than 0 degrees. An acute angle is greater than 0 degrees, but smaller than 90 degrees. Or if you read this in English, it would be anywhere between 0 and 90. You can't stop at 89 and you can't start at 1 because 0.5 degrees is an acute angle. 89.9 degrees is an acute angle. So anything less than 90 but not equal to, bigger than 0. Because in Algebra 2, you're going to start talking about negative degrees. So if you're not prepared for this in Algebra 2, you might not know the whole truth about an acute angle. So if you answered on a daily quiz, test, anything, and you say an acute angle is less than 90 degrees, you're only going to get part credit for it or you'll get it marked wrong. You have to now, from now on in your high school career, say it's smaller than 90 but greater than 0. Which also means that if we talk about an obtuse angle, you might remember that obtuse means big, and you've always been taught that an obtuse angle is bigger than 90 degrees. Half true. Obtuse angles are larger than 90 degrees. But it's also smaller than 180 degrees. So anything from 90.0001 to 179.9999999, you get the point. Anything between 90 and 180 degrees is an obtuse angle. If you only tell me half of it, you're not getting it right. You were only told half-truths in your previous math career because you weren't ready for the whole truth. Right angles, you probably already know this one. I'm not changing it on you. A right angle is exactly equal to 90 degrees. I will tell you this, you can never assume something is a right angle. If it looks like a right angle, doesn't matter. Unless you are told that it's 90 degrees, it's not a right angle. Straight angles, perfectly straight across, exactly equal to 180 degrees. Which means a straight angle looks exactly like a line, or it also looks exactly like opposite rays. So now you're going to get really confused. Opposite rays are technically a line, which is technically a straight angle. True, it works for all of them. Congruent angles, there's that word congruent again. We used it with segments. Congruent angles have to have the exact same measure, but if you talk about the angle, the object itself, the object is referred to as angle A is congruent to angle B. You put an angle symbol in front of it because if we didn't have the angle symbol, we would think it's a point. We don't want it to be a point, we want it to be an angle. If you are comparing two objects, you use a congruent symbol. Make sure that you mark that as a congruent symbol. If you are comparing how big the angle is, for example, 70 degrees, you have to then put an M in front of it. The measure of angle A equals the measure of angle B. If you're talking equals, you're talking size. We already went through this when we talked about segments. If we said segment AB, and because it's an object, we would say that's congruent to segment CD. But if we talked about their measures, we didn't put an M in front of it, we just took the segment bar off. Well, now we have to put an M in front of it. If we take the angle off, it looks like a point. So how do we compare those? Measure of angle A equals the measure of angle B. Pause it if you need to slow down. Adjacent angles have a common vertex and one side. They have one common side. An adjacent angle has a common vertex and one common side. If you take a look at this, you can draw this wherever you have room. I had room up here, so that's where I put it. There are three angles there. Two of them are adjacent. Angle PQR is adjacent to angle SQR. Why are they adjacent? Because they have a common vertex and they share one common side. There is no space in between them. You can't have a space in between them. One ray makes two adjacent angles. And if you think of the word adjacent, adjacent means next to. If you have adjacent neighbors, they're neighbors that are right next to you. More vocab, an angle bisector. You dissected stuff in science, means cut it all up into pieces. Bisect means you're going to cut it into two pieces. And if you're going to cut it into two pieces, you're going to cut it directly in half. A ray that divides an angle into two congruent angles. An angle bisector is a ray, has to be a ray because it has to go continuous, that divides an angle into two congruent angles. We'll draw a picture of that. There's an angle. The angle bisector, go ahead and take your time and draw this in, is ray GM. That's the bisector. And now we have little shortcut markings. If you want to show that two angles are congruent, in the book they'll be red because it's always color-coded. You show that they're congruent by putting two little arc marks. If you need a reminder, when you had a segment with a midpoint, you put two little tick marks in red, showing that those are two congruent segments. In congruent angles, instead of tick marks, you use arcs. So if it asked you to name the angle bisector, you would say ray GM is the angle bisector. All right, a couple other vocabs. Told you there was a lot. The difference between interior versus exterior on an angle. Go ahead and draw a quick angle. This red point is interior. This blue point is exterior. It's outside of the angle. Be careful because this purple point is also interior. because remember that these rays go on infinitely. They keep going and going and going and going and going, which means that point still falls inside or interior of the angle. So don't get thrown off by that of where they stop. Slow down, rewind, pause, whatever you have to. We've got a few left. Angle addition postulate. Should look familiar. You've had the segment addition postulate in the past. Angle addition postulate says if you take the measure of a small angle, PQR, add it to another small angle, RQS, it will equal a large angle, measure of angle PQS. I'm going to show you that with my pens that I use all the time in this class. I'm going to use orange, red, and yellow. Try to show you right here. Okay, if I have the measure of angle PQR, we'll call orange and red PQR. If I add that to angle RQS, oh yeah, that works. Here's PQR, here's RQS, PQR, RQS, the Q is still the vertex. When I'm done, it will equal measure of angle PQS. Here was P, here was S, here was the R in the middle. If I add them together, it equals PQS. Little angle plus a little angle equals a big angle altogether. If this one were 30 degrees and this one were 40 degrees, this would be 70 degrees. Let's draw it so that you have a drawing of it. Put the Q as the vertex. The Q has to be the vertex because it's the one in the middle right here. And we name this angle PQR. We add it to angle RQS. And when you're done, you get the measure of angle. I'll put it in yellow if it lets me. Angle PQS. I guess that's green. Two little angles make a big angle. Okay, now we're going to name angles. We have very, very specific names, and if you haven't caught on already, when you do a line, a segment, a ray, a point, a plane, opposite rays, they all have very specific names. You have to put the segment bar over it, or the double arrow, or the single arrow for a ray. Same thing for an angle. So how are we going to name this parts of this angle? If it says name the vertex, go ahead and pause this and draw this out. Name the vertex. The vertex is a single point. The only thing you will write is capital S. Please don't write point S. Please don't write vertex S. It's just a plain old single S. Name the sides. We kind of already did that in our vocabulary. The sides have to start with the vertex and then go through one of the points. But because an angle is made up of rays, it has to be ray SQ and ray SL. Same initial point, two rays make up the side. And your probably least favorite thing about geometry, the angle that we see there has 4 different names to it. All angles have 2 names. Some angles have 3. Some angles have 4 names. All different names. So when your assignment says, name this angle in 2 different ways, you can always do it. If it says name it in 4 different ways, sometimes you can do it. Here's the trick to naming the angle. You absolutely positively have to put the vertex in the middle. Here's the vertex. If I am naming that angle, first of all, give me an angle symbol so I know it's an angle and not a point or a triangle or a plane. I'm going to start at Q, go through S, and finish at L. Therefore, it's angle QSL. You should be able to draw it exactly in the order that it says without picking up your pencil. But that's the exact same angle as angle LSQ. Again, I did not pick up my pencil. I still was able to trace it and draw the perfect angle, but my S is the vertex, which is in the middle. What you have to be careful of is just throwing down 3 different letters. If I named this angle SQL, and I told somebody to draw angle SQL, that means they would start at S, go through Q, and finish at L. That is not the same angle. It's very, very important that the vertex S gets put in the middle of the angles. And I'm going to go for my infamous no smoking sign. You cannot put Q in the middle, or L. Okay, so all angles have these 2 names. You can name them forward and backwards. This particular angle has 4 names because it has a shortcut. The shortcut to this angle is, if I want to, I can just call it angle S. If I just want to call it angle S, I can call it angle S. Because that angle right there is the only angle that has a vertex at S. Let me flash back up to this angle that we had up here. I cannot, I'm going to erase all this so you can see it better. I cannot call this angle Q. I just told you the other one I could call angle S. I cannot call this angle Q. If I told anybody in this class, or anybody who had in geometry last year, or anybody that's in high school math beyond geometry, find angle Q, they would tell me that there's an angle Q here, there's another angle Q here, there's another angle Q here, and those in Algebra 2 and Pre-Calc would tell you there's a 4th angle Q here. We don't know which one you're talking about if you call angle Q, because 3 different angles have the same vertex. So if an angle is completely isolated and by itself, like this S is, angle S, you can call it angle S. If there's more to it than that, you can't. Not allowed. And finally, the last thing that you can name this, if you can see that right there, there's a little 1. Sometimes they put a 1 or a 2 or a 3, any number inside an angle. If they give you a number, you get to name it by the number, angle 1. And we talked about that with shortcuts with lines and planes having a shortcut. It's because sometimes you might have a diagram that has this many different angles in it. We don't want a Q, an S, a P, a W, a T, an L, and a V, all that in there. We could just name them angle 1, 2, 3, 4, 5, and 6. Much, much easier and a shortcut if you put little numbers in there than if you put a whole bunch of points all over to try to name these angles. That would get pretty messed up and complicated. So, all angles have these 2 names, forward and backwards. Isolated angles have a 3rd name where they have only 1 vertex, 1 angle at each vertex, and some have the shortcut. All right, done with vocabulary, but let's do a little math. Back to algebra, yay. Go ahead and pause this so that you can draw it, write everything in there. The AAP up in the corner stands for the angle addition postulate. We're going to do the angle addition postulate. Pause it, draw it, come on back. All right, you're back. Angle addition postulate says if you take this little angle and add it to this a little bit larger angle, you will get one great big angle. How would we do that mathematically, algebraically? We would take 2x plus 6, angle WXZ, and I'm going to put that up here, the measure of angle WXZ. I'm going to add that to the measure of angle ZXY, and the measure of angle ZXY is 7x minus 3. That's going to equal the big angle, the measure of angle WXY all together. Let me try to get yellow this time. Yellow WXY. If I add that and get to equal to the measure of WXY, it's going to equal 30 degrees. Small angle plus medium angle equals large angle. Do the math on your own if you can. If you can't, follow along. 9x adding like terms plus 3 equals 30. Subtract 3 from both sides. 9x equals 27. Divide by 9 on both sides. X equals 3. Go ahead and show your work. X equals 3. There's an algebra problem again. All you did was answer the algebra. Depends on what the question asks. Is the question asking for x, or is the question asking for the measure of the angles? In this case, it didn't say, but let's answer the angles. If I want the measure of angle WXZ, measure of angle WXZ, I'm going to put a 3 in for x. 2 times 3 is 6. 6 plus 6 is 12 degrees. If I want the measure of the medium angle, I'm not going to subtract these, because if you got this one wrong, you're automatically going to get this one wrong. If you want the measure of angle ZXY, you will write measure of angle ZXY. Take that 3, plug it in right here. 7 times 3 is 21. 21 minus 3 is 18. Don't forget the degrees. Don't forget the measure. If you are asked for the measure of the angle, you write measure of the angle. Now you can double check. 12 plus 18 is 30 degrees. Much shorter problems, just talking about angle bisectors and recognizing the notation. Go ahead and pause it and draw these two. Okay, come on back. Remember that the arcs mean that those are congruent measures. Since they wrote the 23 right in here, that's the measure of angle WQY, which means the measure of angle, write it down, YQD, or you can call it measure of angle DQY, equals 23 degrees also. They have to be congruent because it's an angle bisector. But don't forget, there is a third angle on there. Not only do you have the two little angles, but you also have the measure of angle WQD, this entire angle. How big is the entire angle? If that's 23 degrees and this is 23 degrees, then altogether it is 46 degrees. Two little angles make a big angle. Draw the second one if you haven't yet. Take a look at the label up here. It says the measure of angle PLK. Measure of angle PLK is 74 degrees. If I highlight that, I'll go blue this time. PLK. The whole entire thing is 74 degrees. That means this bisector cut that in half. If I take 74 degrees and cut it in half, I'm going to get 37 degrees for each one of them. It's not okay to just label the diagram. You're going to have to write that out. The measure of angle PLJ equals 37 degrees. And the measure of angle JLK, or KLJ, also equals 37 degrees. So be very careful and read the diagram specifically of what they're telling you. What information do you have? What information do you need? Always when there's a diagram with three rays or an angle, adjacent angles, there's always three angles there. There's always a couple small ones and a big one. So you can always have the measure of 3 different angles. And finally, last one with a little bit of algebra. This is also an angle bisector. It didn't tell you at the top that it was an angle bisector, but you know because of these 2 congruent markings that it's an angle bisector. Go ahead and draw it. If it's an angle bisector, we know that those 2 have been, that the big angle, ZAC, has been cut in half. Unfortunately, they did not tell us how big angle ZAC was. If we don't know the measure of angle ZAC, we can't add them up to make the measure of angle ZAC. So no angle addition postulate for you here. Instead, if you go back and look, the 2 small angles were the same size. They're congruent. These 2 small angles are congruent, which means their measures are equal. If their measures are equal, we don't need a large angle. If the 2 measures are equal, we can do the math and solve for x as is. Go ahead and solve it. I'm going to minus 3x from both sides, just so I'm working with a positive number. I'm going to add 2 to both sides, and I will get 20 equals x. That might be good enough if it just asks for x, but you should always check your answer. If I put a 20 in for x here, 3 times 20 is 60, plus 18 is 78 degrees. 4 times 20 is 80. 80 minus 2 is 78 degrees. Always check your work if you've got an extra moment. All right, deep breath. That was a lot of math, a lot of geometry, a lot of algebra mixed in, a lot of vocabulary. Loosen up. Take a break. Don't go into your assignment right away. This took long enough. Maybe get after your assignment later today or tomorrow or something so that you can come back and revisit angles. A lot of information about angles. But that's it. The end of your notes.